Hi everyone, welcome to today's session where we will cover incremental scans for Amazon S3 and Snowflake. The agenda for today's session would be covering the incremental scan for both Amazon S3 and Snowflake. We'll see the introduction for incremental scans and the basic requirement behind them. We'll also see the initial run configuration with examples for both these catalog source types. And we'll also see the possible scenarios in which incremental scan can be used and what to expect in those possible scenarios. We'll also refer to the supported objects in Snowflake incremental scan in this session. Going ahead, incremental scans. So an incremental scan can process only new or modified data from the source since the last successful scan, making it faster and more resource efficient by avoiding redundant data scanning. Now the next question comes, why the incremental scan is required? We perform incremental scans to save time and resources by processing only new or changed data since the last scan, rather than scanning the entire dataset. This approach keeps data in sync more efficiently, reduces the load on the system, and enables faster, up-to-date insights without redundant processing. The incremental scan can majorly help in those possible scenarios where we have to scan the catalog source on a daily or a weekly basis. And instead of scanning the entire data set or the entire database, we'll only be scanning those objects which are modified or which are added recently after the last run of the scan. Going forward, we'll see the initial run and the configuration required for the initial run of Amazon S3 scans. So first of all, the requirement is to create a Amazon S3 catalog source configuration in metadata command center. And during the first run, the only option available to us will be the full load scan. The incremental scan would be disabled for the initial run while running the catalog source scan, because the first run or the initial run will have to mandatorily capture all the data provided in the configuration filter options for the S3 catalog source configuration. Here we'll see an example where an initial run with full metadata load is executed. Now we see the scan is completed for an Amazon S3 and two flat files are extracted as part of the initial run of Amazon S3 scan. We can see the result of the initial scan in the CDGC UI as well. We are seeing that order underscore details underscore colon.csv and Chinese.csv flat files are extracted as part of the initial run of Amazon S3 scan. Now let's consider a scenario where we are adding new files to the existing folder configured in the initial metadata scan. Suppose we are adding another file called customer underscore semicolon.csv in the same folder which has been configured in the initial metadata scan. Now, when we run the scan again for the Amazon S3, we'll get two options. Either we'll have to run the entire full load scan, which will again extract the already extracted two files, or we'll have an option to run the incremental scan. When we select the incremental scan, we will instruct the scanner to only extract the modified files or the files which are added after the successful incremental scan run. Upon running the incremental scan, we'll see that only one flat file has been extracted. The remaining two files which were already present in the catalog, which were extracted in the initial run, have not been extracted as part of the incremental run of the scan. This helps us in scanner performance. It saves us time and resources while executing the scan. We can also see the scan results in the CDGC UI. Now we are seeing there are three files instead of the two present after the initial scan. And the benefit of using it as an incremental run is that in the second scan, we only had to scan one file instead of scanning all the three files. Now let's consider another scenario. In this scenario, we'll only be adding the rows in the existing files which are already present inside the folder configured in the catalog source configurations. In this scenario, we run the incremental scan based on the last modified date of files. If last modified date is later than the original or initial scan date, then only those files would be scanned. If the last modified date of the folder is changed and is later than the previous scan date or the initial scan date, all the files inside this folder will be scanned under the incremental scans going forward. The next scenario here, we can see the effects of change in filter conditions on incremental load or incremental scan. So if the last modified date of added folder in the filter condition is later than the date or timestamp of the initial load or subsequent incremental scans, then only the added folder in filter condition would be scanned. If the last modified date of added folder in the filter condition is older than the date or timestamp of initial load or subsequent incremental scans which are successful, then that folder would not be scanned as part of incremental scans. This is happening because the design of the scan is to extract metadata or objects based on the last modified date. If the last modified date is older than the last successful run, either that is initial or incremental run, then those files would not be extracted. If the last modified date is later than the last scan run, then all those files would be extracted. Going forward, let's consider a scenario where the incremental scan status is failed or is in completed with errors state. As explained in the previous slide, the first or initial run always has the option of complete load. The first incremental scan is completed successfully with no errors, and the subsequent incremental scan is completed with errors. Under this situation, the last modified date for the scan will always be considered for the success state run of the scan. The next scan run will scan again all the files which are modified later than the date of successful run of the scan. So if the scan status is currently in completed with errors state, the last modified date of the scan run will be the previous scan run which is in successful state. Now let's check about the incremental scan for Snowflake and what are the differences between the configuration and behavior of incremental scan in Snowflake as compared to Amazon S3. So the basic design of these scanners for incremental scan for Snowflake is similar to that of Amazon S3. Incremental scan is only used to process new and modified data from the source instead of scanning the entire metadata and data from the data source systems. One important thing to check here is the supported objects in Snowflake incremental scan. The incremental scan supports only the below mentioned objects from Snowflake as of now. These objects include database, schema, tables or columns, views, view columns or materialized views, and external tables. One thing to note here is stored procedures are not yet supported for incremental scan in Snowflake. The initial run configuration is similar to that of Amazon S3 in Metadata Command Center. we'll have to first create a Snowflake catalog source configuration in MCC. And during the first run, the only option available would be that of full load scan as present in Amazon S3. The incremental scan will be disabled for initial run because in the first run we have to scan all the metadata and data provided in the filter conditions. Once the once the initial scan or initial metadata load is completed successfully, we can see that in the subsequent runs we have an option of using incremental scans in Snowflake as well. If we make any changes or modify any files or tables present inside the data source system, we can use the option of incremental scan instead of the full last scan option. One use case scenario here is if the new files or new tables are added to existing folders configured in the initial metadata scan and we run the incremental scan, then only the added tables, views, or files would be visible in the metadata extraction of incremental scans. Instead of scanning the complete metadata and data again, we'll only extract the new added uh, tables or views or objects in the given filter condition. Going forward to another use case scenario that could be adding or altering or modifying the metadata of the table or the view which is already extracted during the initial run or during the previous successful run of the incremental scan. The design behavior is the modified data. Only the modified data or metadata would be extracted when we run the incremental scan. Another scenario where we can run the incremental scan is when we delete the metadata of the table or the view. Under this scenario, nothing will be extracted as part of the incremental scan. And in the sync log, it will be mentioned as no change in the source system. Now, there are scenarios where the Snowflake incremental scan differs from the incremental scan of Amazon S3 scans. These scenarios include adding a record in the table or view column. The tables or view columns would not be extracted as there is no change in the modified date of the table or view column. We only extract the tables or objects whose table definition date is later than the date of last incremental scan, which is successful. Another scenario to consider is changing the filter conditions after the initial run or initial load. If we change the filter conditions in the catalog source configuration, it is recommended to perform a full scan or a full load scan. If we perform the incremental scan after changing the filter conditions in catalog source configuration, it will only extract the modified objects from the initial or existing filters and no objects from new filter would be extracted. This is a design change from the Amazon S3 as compared to the Snowflake incremental scan. In Amazon S3, we would be scanning the new folders provided in the filter conditions if their last modified date would be later than the last successful incremental scan. But in Snowflake, we would not be extracting any new filters or new folders provided in the new filters after the successful run of incremental scan. We will now be covering a short demo of how to configure the initial run and how to run the incremental scan from metadata command center. As we have already discussed on the use case scenarios and scanner behavior of incremental scan for both Snowflake and Amazon S3 under different use case scenarios, we'll now check the steps on how to run the incremental scan, which is same for both the catalog source extractions. First, we'll have to create a catalog source under metadata command center provide the general information under the registration tab, and provide with the connection information and runtime environment. Then we move on to configuration tab and provide the metadata change options and filter options. Once we provide the filter options and after the initial run, if we make any changes, we have an option to provide the scanner an option to run either in full mode or in incremental scan mode. Here, if we click on run, we'll have an option to either select full or incremental. If we are running the scan for the first time, incremental option will be disabled, and in the subsequent scans, if we want to run only the incremental scan for extracting the updated or modified metadata and data, we can select incremental run. If we want to select the entire metadata option provided in filter and run the scan again, we'll click on the full option and click on run to execute the scan. This is how we can run either full or incremental scan for Snowflake and Amazon S3 in metadata command set. We would love to hear from you. Please reach us on supportvideos@informatica.com or on our official InfoSupport Twitter handle. Thank you.